because of when you take this, you don't have any phi L star phi L. You take the phi normal. So psi is normal. So this, after the whole story, so you find that this is a 1 if and only if, of course, if k equal to k prime, yes, is 1. And if k is not k prime, is 0, because this is the definition of wave function. Different wave function, this is called overlap. The overlap of different wave function gives you 0, and overlap of the same wave function gives you 1. So this is the case of it can be 1. So after all this tragedy, so you can be sure that I will back it here. I can tell you that this is delta L, k and k prime. I proved that. So the 1 sigma can be jumped from here, huh? 1 sigma can be jumped from here, and k will be equal to k prime. Here, remember that here there is no star here. Here there is no star. I put it the star by the wrong. So right there. And you have a sigma A, huh? You have a sigma A, k prime something which is no 1. Just delta k. This is gives you 1n, huh? And n by n cancel. So you get 1 over n. Rnk star Rnk, what is that? If k is equal to k. This is rho and m. So we prove this proof needed actually 2 black holes, but we just make it really compact. So actually this was the review of the quantum mechanics. All the quantum mechanics is rheostat. Give me the Hamiltonian, I find for you the set of the complex functions. The state of the system is written in terms of the superposition principle, in terms of the possible wave function of the system. And the amplitude for each one is given by this integral. That's all the quantum mechanics. All. So these are not the real functions. So this function I call it in Sokolov. They are defined in Sokolov space, so they are not real real functions. They are distributions. And Dirac used this first time for the purpose which we use it now. He used it that first time. He introduced this first to the physical physics, Dirac, in his book. In his book called Foundation of Quantum Mechanics, P.R.M. Dirac. Foundation of Quantum Mechanics. Actually, when I was studying the physics in the bachelor and master, I was looking for the person to. I was always very relaxed with Dirac because I like the way he teach the quantum mechanics. So this is a very is the first book, as I know, is the first book about the quantum mechanics. The first book. It's very fantastic because you can read this book from the beginning. You don't need it to know like other quantum mechanics book. It's the best book, I think.
Doctor, can we get Hamiltonian from unreal functions? Because you say this is
Hamiltonian what?
Hamiltonian from this not. You said this is not real. It is a distribution.
Yes.
How can we get the Hamiltonian from?
No, you will confuse it. You know, to find this phi L, the element of this space, you need to give me Hamiltonian. Okay. If you give me Hamiltonian, I can give you the set of the function. And if you give me that, I can expand any function for you. So delta x minus x prime, it can be the wave function the system, the state of the system. It can be the state of the system. You know what is the wave function of what this? Which kind of the particle can have this kind of the wave functions, you know? Like this. Localized function, huh? Localized function. X should be exactly near to x prime, huh? It means that you fix the function at x prime. So this is the wave function. It can be interpreted as the wave function of the localized particle. Localized. It's very deep, but there is many books about this distribution, about just this function, because this function is very important in analysis also for mathematicians. So that was the one which I was planning to prove. I was very unhappy about the proof of the last lecture. So this is the full proof actually with all the detail. So you needed to know that this rho, the density matrix, is very strange, has a very strange character. So, I mean, now I want to back to the example of the ensemble, which kind of the ensemble we know, and there is the first ensemble which I want to write in terms of the rho matrix is the microcanonical. So microcanonical ensemble was the ensemble which all the state has the same probability. Or from different point of view, the energy was bounded in the range of the energy, we call it gap. So I want to tell you that, so writing different ensemble in terms of matrix rho. The first example is microcanonical. It's very, you know that microcanonical is very poor approximation. Huh? It means that you don't have any information about the temperature or distance. So canonical was you fix the temperature of the system. So here you don't have any information about the system, not very much information. The only thing was that you know that the band of the energy. They are equiprobabilities. BT states. They are equiprobability states. So each state has the same probability with the other one. So if